Now we're going to prove that the cosine of the sine inverse of x is given by the square root of 1 minus x squared, with x between -1 and 1. To solve this problem and get all the results that we need, note that the sine inverse is defined on -1, 1, and it has values on minus pi over 2, pi over 2. This is very critical to solve this problem. Here, if we let this sine inverse of x equal some alpha, we note that the cosine of alpha is going to be in this one, in this minus pi over 2, pi over 2. So alpha is between minus pi over 2. Let me do it one more time. So alpha, the angle, is going to be between minus pi over 2, pi over 2. And therefore, the cosine is always going to be positive. You take any alpha in here, okay? Take any alpha, the cosine is going to be positive. Take this alpha, the cosine is positive. Take this alpha here, the cosine is going to be positive, okay? Therefore, here we see that we have the cosine of alpha is always positive. Now, using our Pythagorean identity, we have the cosine squared of alpha plus sine squared of alpha is 1. Okay, now we can solve for the cosine. We get 1 minus sine squared of alpha, and we have the cosine of alpha is plus minus 1 minus sine squared of alpha. But we're going to get rid of the minus because the cosine is always positive. Therefore, we have only 1 minus sine squared of alpha. Okay, now we rewrite our expression as 1 minus sine squared of sine inverse of x. Now the sine inverse, the sine of the sine inverse of x is just x, because x is between -1, 1, and the sine of x is between, sine inverse of x is between minus pi over 2, pi over 2. Therefore, we have a projection here, and we have just x, okay? And this proves our result that we need, okay? This shows that the cosine of the sine inverse of x is just 1 minus x squared, with x between -1 and 1. Okay? We have it from here. We can't define this function without x being in this interval, -1, 1, as a composite function. And therefore, we have shown that the cosine of the sine inverse of x is just square root of 1 minus x squared. Okay? We can use it, or we can prove it using geometry, but algebra is great as well. So we will stop here. Thank you very much.